Hello students, Maurice here. In the previous lecture we discussed some examples based on relations, and today we are going to see our next point is binary relation on a set. Binary relation on a set. What is the definition of that? Binary relation of a set. Let capital let A be any non-empty set. Let A be any non-empty set, then every subset of A cross A, that is Cartesian product of A and A. Cartesian product of A and A is called the binary relation on a set A. Definition, I repeat once again. Let A be any non-empty set, then any or then every subset of A cross A is called the binary relation on a set A. What is the definition of binary relation on a set? Let A be any non-empty set, then every subset of A cross A is called the binary relation on a set A. Is called the binary relation on a set A. For example, if we take, let A equal to set containing 1, 2, 3. Let A equal to set containing the elements 1, 2, 3, and R equal to, suppose I take 1, 2, then next 2, 2, then next 3, 1 and 3, 2. If I take R equal, then is it R is binary relation on a set A? R हे binary relation on set A आहे का? चेक करण्यासाठी. Then for that definition what? A be a non-empty set, then every subset of A cross A is called the binary relation on set A. Therefore first we have to find A cross A. A cross A means what? Therefore first we will find A cross A, which is equal to A cross A means what? Cartesian product of two sets, but here set is same A and A. We know that. What we know that? If A and B are any two non-empty sets, then Cartesian product of A and B, which is equal to set containing the elements or set containing all order pairs A, B, such that first component of that order pair A belongs to the first set A and second component of that order pair belongs to the second set B. These denote Cartesian product of two sets. Therefore, by that definition, Cartesian product of A cross A, which is equal to set containing all order pairs A, B, such that first component A belongs to the first set A and second component of this B belongs to the second set. But here second set also A. It means A cross A contains all order pairs such that order pairs, प्रत्येक order pairचा first component second component belongs to the set A. means set A मधील जेवढे एलिमेंट्स आहेत त्या एलिमेंट्स पासून जेवढ्या ऑर्डर पेयर्स मॅक्झिमम ऑर्डर पेयर्स तयार होतील त्यांचं कलेक्शन म्हणजेच मिळेल आपल्याला A क्रॉस A. देअरफॉर A क्रॉस A which is equal to set containing the elements we get first order pair 1, 1, then second order pair we can write 1, 2, then third one is 1, 3, then next one is 2, 1, 2, 1, then next we get 2, 2, then next we get 2, 3, next we get 3, 1, 3, 2, 3, 3, 3, 1, then next 3, 2, and next 3, 3. This is what Cartesian product of A cross A. We get A cross A. Now here we observe that is it R is subset of A cross A? Obviously R is subset of A cross A. Why? We observe that every element of R is also an element of A cross A. That is R is subset of A cross A. म्हणजेच काय झालं? R मधील प्रत्येक एलिमेंट हा A cross A याच्यामध्ये आहे. Therefore आपण म्हणू शकतो R is subset of A cross A. R is subset of A cross A. Therefore by definition we say that what we know that let A be any non-empty set and let A be any non-empty set, then every subset of A cross A is called binary relation on A. Therefore इथे काय मिळतं आपल्याला? हा R आहे तो या A cross A चा सबसेट मिळतोय. Therefore आपण म्हणू शकतो therefore we say that R is binary relation on A or R is relation on set A. Simple. R is relation on set A. Next line काय होईल? Since R is subset of A cross A, काय येईल? Therefore R is proper subset of A cross A. Proper subset म्हणजे काय? A मध्ये एक तरी एलिमेंट एक्स्ट्रा आहे. आर पेक्षा, देअरफॉर प्रॉपर सबसेट, अँड वी नो दॅट प्रॉपर सबसेट असेल तर तो सबसेट सुद्धा असतो, सबसेट सुद्धा असतोच. देअरफॉर आर इज सबसेट ऑफ ए क्रॉस ए. देअरफॉर वी सी दॅट आर इज रिलेशन ऑन ए or R is binary relation on A because two sets are same. Therefore we say that R is binary relation on a set A. R is binary relation on a set A. Simple definition. Now next point is their properties of relations. Properties of relation. Properties of binary relation. Properties of binary relation. Properties of binary relation. Next point is properties of binary relation. Therefore first one is let A be any non-empty set. Let A be any non-empty set. Non-empty set. Let A be any non-empty set, and right. Let A be any non-empty set. Then a relation are on set A, defined on set A, is said to be first one reflexive, is said to be reflexive. Here, let A be any non-empty set, then a relation R defined on set A is said to be reflexive. Then a relation R on A is said to be reflexive. Condition not if order pair A belongs to relation R, and this is for all A belongs to the set A. Then you say that the given relation R is reflexive. It means what? Let A be any non-empty set, and let A be any non-empty set, then a relation R defined on A is said to be reflexive. Condition not if order pair AA belongs to that relation R, and which is for all A belongs to A. म्हणजे काय, रिलेशन आर मध्ये अशा ऑर्डर पेअर्स हव्या आहेत, त्या ऑर्डर पेअरचा फर्स्ट कॉम्पोनंट सेकंड कॉम्पोनंट सेम, बट इथले जे फर्स्ट कॉम्पोनंट सेकंड कॉम्पोनंट सेम, पण ते कॉम्पोनंट कुठले पाहिजेत, ऑल दी बिलॉंग्स टू दी सेट ए. फॉर एक्झाम्पल याचं म्हटलं तर सपोज लेट ए इक्वल टू सेट कंटेनिंग 1 2, ए बी एनी सेट, अँड आर बी अ रिलेशन डिफाईन ऑन ए, असं डिफाईन केलं 1 1, सेकंड वन इज 1 2, हिअर आय टेक 1 3 also, and 1 1 1 2, then next 2 1 and 2 2, and I take 3 1 also. Okay, let A equal to set containing the elements 1 2 3, and R equal to set contains order pair 1 1 1 2 2 1 2 2 3 1. Therefore we see that R is relation, R is binary relation on a set A. R is binary relation on a set A. Now is it reflexive relation? What definition? What a relation R defined on a set A is said to be reflexive if order pair AA belongs to the relation R for all A belongs to A. Means A मधील प्रत्येक इलेमेंट्सच्या सेम. इट मीन्स फर्स्ट एलिमेंट वॉट 1, देअरफॉर रिलेशन आर मध्ये 1 1 ऑर्डर पेअर हवे. देन नेक्स्ट सेकंड एलिमेंट 2, देअरफॉर रिलेशन आर मध्ये 2 2 ऑर्डर पेअर हवे आहे. अँड देन नेक्स्ट एलिमेंट 3, रिलेशन आर मध्ये ही सुद्धा ऑर्डर पेअर हवे 3 3, बट या रिलेशनमध्ये दिस ऑर्डर पेअर नॉट 3 3 ऑर्डर पेअर नाही. देअरफॉर दिस रिलेशन इज नॉट रिफ्लेक्सिव्ह. जर या रिलेशनमध्ये 3 3 ही ऑर्डर पेअर असती तर आपण म्हणलं असतं दिस गिवन रिलेशन इज reflexive relation. Means reflexive, when we say that reflexive, let A be any non-empty set and R be a relation on A is said to be reflexive if order pair AA belongs to the relation R for all A belongs to A. Then we say that the given relation is reflexive. It means relation R मध्ये अशा ऑर्डर पेअर्स हवेत की त्या ऑर्डर पेअरचा फर्स्ट कंपोनंट सेकंड कंपोनंट सेम हवा आहे आणि ते ऑल कंपोनंट एमध्ये हवेत. म्हणजे एमध्ये जेवढे एलिमेंट्स असतील जेवढे एलिमेंट्स कलेक्ट करून सेम ऑर्डर पेअर्स हवेत. फॉर एक्झाम्पल आपण काय घेतलं, लेट ए इक्वल टू सेट कंटेनिंग 1 2 3, ए इक्वल टू सेट कंटेनिंग 1 2 3 अँड आर इक्वल टू सेट हा डिफाइन केला. सपोज न्यू ऑर्डर पेअर ऑर्डर विथ 3 3 याच्यात ऑर्डर. Obviously R is binary relation on a set A. Now is it this given relation, is it reflexive or not? Reflexive definition or not? By that definition here in A element there are 1 2 3. Therefore first element 1 1, therefore relation R मध्ये 1 1 ऑर्डर पेअर आहे का? आहे. सेकंड एलिमेंट 2 relation R मध्ये 2 2 ऑर्डर पेअर आहे का? आहे. Then third one element is 3. Therefore in relation R there is order pair 3 3 present आहे का? आहे. Therefore we say that the given relation R is reflexive. If 3 3 प्रेझेंट नसता किंवा 1 1 प्रेझेंट नसता किंवा 2 2 प्रेझेंट नसता तर आपण म्हटलं असतं given relation is not reflexive. Therefore we say that it is reflexive relation. Now next one is A be any non-empty set, then a relation R on A is said to be symmetric. Is said to be symmetric if condition what, if order pair AB belongs to relation R, that implies order pair BA also belongs to the relation R, and which is for all AB belongs to the relation belongs to the set A. For all AB belongs to the set A. This notation denotes for all. This notation we use for all. That notation denotes for all. Now here let A be any non-empty set, and then a relation R defined on a set A is said to be symmetric. Condition what, if order pair AB belongs to the relation R, that implies order pair BA also belongs to the relation R. असं जर असेल तर आपण म्हणू शकतो the given relation is symmetric. Given relation is symmetric. The next one is, third one is transitive. Let A be any non-empty set, then a relation R defined on A is said to be transitive. If order pair AB belongs to relation R and order pair BC belongs to the relation R, that implies this whole implies then order pair AC also belongs to the relation R, which is for all A B C belongs to the set A. Then you say that अशी कंडिशन असेल तर आपण म्हणू शकतो given relation is transitive. Condition what, let A be any non-empty set, then a relation R defined on A is said to be transitive if order pair AB belongs to R and order pair BC belongs to R. असं असेल order pair AB belongs to the relation R and order pair BC also belongs to the relation R, then order pair AC belongs to the relation R, ही सुद्धा ऑर्डर पेअर त्या रिलेशन मध्ये असेल तर आपण म्हणू शकतो द गिवन रिलेशन इज ट्रान्झिटिव्ह. इट मीन्स ऑर्डर पेअर AB असेल, ऑर्डर पेअर BC असेल, देन त्याच्यावरून जर ऑर्डर पेअर AC सुद्धा आली त्या रिलेशन मध्ये तर आपण म्हणू शकतो गिवन रिलेशन इज ट्रान्झिटिव्ह. ठीक आहे. फर्स्ट वन वाज लेट A be any non-empty set, then a relation R defined on a set A is said to be reflexive if order pair AA belongs to relation R for all A belongs to A. And second one, relation R is said to be symmetric if order pair AB belongs to relation R, that implies order pair BA also belongs to the relation R, and which is for all AB belongs to the set A. And third one is the given relation is said to be transitive if order pair AB belongs to relation R and order pair BC belongs to relation R, that implies order pair AC also belongs to the relation R, and which is for all ABC belongs to the set A. Then we say that the given relation is transitive. Now a relation which is reflexive, symmetric and transitive. एखादं रिलेशन तीन सुद्धा असेल, एखादं रिलेशन असेल ते रिलेशन रिफ्लेक्सिव्ह सुद्धा असेल, सिमेट्रिक सुद्धा असेल, ट्रान्झिटिव्ह सुद्धा असेल तर त्या रिलेशनला दॅट रिलेशन वी कॉल equivalence relation. That relation is called equivalence relation. Now therefore our next definition is a relation which is reflexive, symmetric and transitive is called a equivalence relation. Therefore, take our next point. Therefore, our next point is equivalence relation. Equivalence relation definition: what? A relation which is reflexive, symmetric and transitive is called a equivalence relation. म्हणजे एखादं रिलेशन रिफ्लेक्सिव्ह प्रॉपर्टी सॅटिस्फाय करत असेल, द नेक्स्ट सिमेट्रिक प्रॉपर्टी सुद्धा सॅटिस्फाय करत असेल, अजून एक ट्रान्झिटिव्ह प्रॉपर्टी सुद्धा सॅटिस्फाय करत असेल, या तिन्ही प्रॉपर्टी सॅटिस्फाय करत असेल तर त्या रिलेशनला आपण म्हणू शकतो इक्विव्हॅलन्स रिलेशन. इक्विव्हॅलन्स रिलेशन. देअरफॉर टेक वन एक्झाम्पल बेस्ड ऑन दॅट इक्विव्हॅलन्स रिलेशन. फॉर एक्झाम्पल हिअर फर्स्ट let R be a relation on Q, where Q means what? Q is a set of rational numbers. Q is a set of rational numbers and is defined by, let R be a relation on Q defined by R relation defined as R equal to set containing all order pairs A B such that first component and second component belongs to set of rational number Q, and one more condition, and subtraction of first and second belongs to the Z means set of integer. ठीक है. Let R be a relation on Q means set of rational numbers defined कसे गेले? R equal to relation R contains all order pairs A B such that these two components belongs to set of rational number, and if we take subtraction of these two components we get answer. This answer belongs to set of integers Z. Then our question is that then show that R is an equivalence relation. Then show that this R is an equivalence relation. ठीक आहे. आपल्याला काय शो करायचं आहे? R हे इक्विव्हॅलन्स रिलेशन शो करायचं आहे. You know that a relation which is reflexive, symmetric and transitive is called as equivalence relation. Therefore आपल्याला काय करावं लागेल? हे जे रिलेशन R आहे ते इक्विव्हॅलन्स, सिमेट्रिक अँड ट्रान्झिटिव्ह या तिन्ही सुद्धा प्रॉपर्टी सॅटिस्फाय करते असं दाखवावं लागेल. देन लास्ट वी कॅन राईट this relation is reflexive, symmetric and transitive. Therefore we see that the given relation is equivalence relation. Therefore first in solution how we will start solution? First in solution this given information. First in solution how we will start? In solution let R start this. Let R these two lines as it is. पहिल्या दोन लाईन्स as it is. सोल्युशन मध्ये काय होईल? लेट आर बी अ रिलेशन ऑन क्यू मीन्स सेट ऑफ रॅशनल नंबर्स डिफाइंड कसं केलंय? आर इक्वल टू सेट कंटेनिंग ऑल ऑर्डर पेअर्स ए बी सच दॅट दीज टू कंपोनंट्स बिलॉंग्स टू सेट ऑफ रॅशनल नंबर्स क्यू, अँड सबस्ट्रॅक्शन ऑफ दीज टू बिलॉंग्स टू झेड मीन्स सेट ऑफ इंटीजर्स. देअरफॉर नेक्स्ट लाईन व्हॉट वी हॅव टू शो दॅट वी हॅव टू शो आपल्याला काय शो करायचं आहे? हे जे गिवन रिलेशन आर आहे ते इक्विव्हॅलंट शो करायचं. मीन्स पहिल्यांदा आपण शो करणार रिफ्लेक्सिव्ह प्रॉपर्टी, देन नेक्स्ट सिमेट्रिक अँड ट्रान्झिटिव्ह. तिन्ही प्रॉपर्टी सॅटिस्फाय केल्या तर आपण म्हणू शकतो गिवन रिलेशन इज इक्विव्हॅलन्स रिलेशन. देअरफॉर नेक्स्ट लाईन फर्स्ट वन इज रिफ्लेक्सिव्ह प्रॉपर्टी व्हॉट? ऑर्डर पेअर ए बिलॉंग्स टू रिलेशन आर फॉर ऑल ए बिलॉंग्स टू ए. ऑर्डर पेअर ए मीन्स ऑर्डर पेअर ए बिलॉंग्स टू रिलेशन आर या रिलेशनमध्ये आली पाहिजे. जर ऑर्डर पेअर ए या रिलेशनमध्ये असेल तर काय होईल? ऑर्डर पेअर ए बिलॉंग्स टू या रिलेशनमध्ये असेल तर काय होणार? ए बिलॉंग्स टू रॅशनल नंबर अँड सबस्ट्रॅक्शन ऑफ ए मायनस ए बिलॉंग्स टू सेट ऑफ इंटीजर. अशी कंडिशन सॅटिस्फाईड केली, ती कंडिशन सॅटिस्फाय झाली तरच आपण म्हणू शकतो ऑर्डर पेअर ए बिलॉंग्स टू द रिलेशन आर. हिअर यू नो दॅट हिअर फर्स्ट एक्सप्लेन लेट ए बिलॉंग्स टू क्यू. Suppose if we take A belongs to is any rational number, A belongs to Q, then if we take subtraction A minus A which is equal to answer 0, and 0 is what? 0 is integer. set of integers starting with 0 plus or minus 1 plus or minus 2 up to so on. Therefore 0 also is an integer. Therefore 0 goes to 0 belongs to z. 0 belongs to set of integers. 0 belongs to set of integer. Therefore we say that a minus a also belongs to set of integer. Here a minus a belongs to set of integer. Now by the definition of that relation R, relation R की definition क्या है? Order pair AB belongs to relation R when these two components belongs to Q and subtraction of these two components belongs to Z. Now here what we show, first आपण घेतलं A belongs to Q, A belongs to Q, then आपल्याला काय then आपण काय केलं, then A minus A equal to काय होतो 0 which is belongs to Z. These property satisfied, these property same, therefore आपण काय म्हणू शकतो, therefore we say that order pair A belongs to the relation R. Why this belongs to the relation R? Order pair A belongs to relation R. Why? Because this satisfies this property. Satisfies no. Here AA belongs to Q. And suppose if you take subtraction A minus A which is equal to what? 0, and we know that 0 is an integer. 0 belongs to Z. Therefore this also belongs to Z. Is by that property we say that what we say that order pair AA belongs to relation R. And order pair A belongs to relation R. Therefore we say that what we say that therefore R is an reflexive relation. Therefore next line, therefore we say that R is reflexive. R is reflexive. Therefore we get R is reflexive. The next one we have to show R is symmetric. Then we have next we have to show R is symmetric. Therefore second symmetric. Second we have to show R is symmetric. You know that when R is symmetric, let A be any non-empty set and R be a relation defined on A, then R is said to be symmetric if order pair AB belongs to R, that implies order pair BA also belongs to relation R. Then we say that R is symmetric. Therefore आपल्याला काय करायचं आहे, this given relation is symmetric show करा. Therefore first आपण घेणार order pair AB belongs to relation R, त्याच्यावरून आपल्याला शो करावं लागेल order pair BA also belongs to relation R. असं शो केलं तर आपण म्हणू शकतो given relation is symmetric. Therefore first take let order pair AB belongs to the relation R. Let order pair AB belongs to the relation R. Now therefore now this order pair AB belongs to relation R. Now order pair AB belongs to relation R. AB relation R मध्ये जातो. म्हणजे प्रॉपर्टी काय होईल, AB belongs to R. तेव्हा दिस प्रॉपर्टी सॅटिस्फाय होते. काय होणार, A minus B belongs to Z. A minus B belongs to Z. Therefore now AB belongs to relation R. Therefore that implies A minus B belongs to where? Z. Belongs to where? Z. Set of integer A minus B belongs to Z. That is आपण काय म्हणू शकतो, that is A minus B belongs to Z. म्हणजे काय होणार, A minus B is an integer. Belongs to Z. Z means what? Set of integers. Therefore we get A minus B is an integer. Now A minus B is an integer. Next line we do, if we take common, आपण जर common घेतला minus तर काय होईल, minus common घेतल्यानंतर minus होईल bracket B minus A minus common घेतल्यानंतर is also an integer. Same is an integer. Again we get is an integer. Now next minus in bracket this is an integer. We know that what is that? Set of integer starting with 0 plus or minus 1 plus or minus 2 and up to so on. Here plus 1 integer, therefore minus 1 also integer. Then by that here minus this integer, therefore we say that therefore B minus A is an integer. B minus A is an integer. That is how to say. That is B minus A belongs to where? Set of integer Z. B minus A belongs to Z. Now B minus A belongs to Z. Then B minus A belongs to Z. Then by property of that relation R, A minus B belongs to Z. Then we say that order pair A B belongs to R. इथं काय मिळालं आहे, B minus A belongs to Z. Therefore by that property we say that order pair BA belongs to the relation R. Order pair A BA belongs to relation R. Therefore thus आपल्याला काय मिळालं, thus आपण काय घेतलं होतं, order pair AB belongs to R. That implies आपल्याला मिळालं order pair BA also belongs to relation R. Therefore we say that the given relation is symmetric. Therefore we say that given relation is symmetric. Why symmetric? Symmetric property काय आहे? If order pair AB belongs to R, that implies order pair BA also belongs to R. Then we say that the given relation is what? Symmetric. For that we take let AB belongs to relation R. आपण consider केलं let order pair AB belongs to relation R मध्ये घेतली. But order pair AB belongs to R मध्ये घेतली. Now order pair AB belongs to जेव्हा R घेतो तेव्हा by definition of that R, order pair AB belongs to R, then A minus B belongs to a set of integers. Therefore from that we get A minus B belongs to Z, and Z is what? Set of integers. Therefore we say that A minus B is an integer. Now A minus B is an integer. Next line काय केलं आपण? Just common काढला minus. Minus in bracket काय आलं? B minus A is an integer. And we know that what? We know that set of integers starting with 0 plus or minus 1 plus or minus 2 up to so on. Plus or minus 1 integer. 1 integer असेल तर मायनस 1 सुद्धा इंटिजर असतो. देअरफॉर बाय दॅट आपण काय म्हणतोय? मायनस हा इंटिजर आहे. देअरफॉर मायनस काढलं तरी सुद्धा 2 इंटिजर्स राहते. म्हणजेच आपल्याला मिळते बी मायनस ए इज अन इंटिजर. नाव बी मायनस ए इज अन इंटिजर. दॅट इज आपण काय म्हणू शकतो? बी मायनस ए बिलॉंग्स टू सेट ऑफ इंटिजर झेड. नाव बी मायनस ए बिलॉंग्स टू झेड. हिअर ए मायनस बी जेव्हा झेड मध्ये जातो तेव्हा ऑर्डर पेअर ए बी बिलॉंग्स टू आर होतो. इथं काय मिळालं आपल्याला? बी मायनस ए बिलॉंग्स टू झेड. देअरफॉर आपण म्हणू शकतो ऑर्डर पेअर बी ए बिलॉंग्स टू रिलेशन आर. दस आपल्याला काय मिळालं? दस इफ फर्स्ट आपण घेतो होतं इफ ऑर्डर पेअर ए बी बिलॉंग्स टू रिलेशन आर, दॅट इम्प्लाइज ऑर्डर पेअर बी ए ऑल्सो बिलॉंग्स टू रिलेशन आर. देअरफॉर वी से दॅट नेक्स्ट लाईन इथं येईल. देअरफॉर वी से दॅट द गिवन रिलेशन आर इज सिमेट्रिक. गिवन रिलेशन आर इज सिमेट्रिक. Given relation R is symmetric. Now last only there is किती मिनिटं